All right, today's lesson is on biconditionals and definitions. A biconditional is, we're taking off from what we talked about today when we're talking about conditional statements. A conditional statement basically said if P then Q. A biconditional statement is a little different. It's when the statement itself is true and the converse of the statement is true. We'll say if P, or P if and only if Q, which means that P implies Q and Q implies P are both true in all instances. So today's lesson is on biconditionals and definitions. Start out, we're going to review a hypothesis. Remember that the hypothesis in each statement follows the if sign. So number one, if it rains on Friday, I won't have to cut the grass on Saturday. It rains on Friday is the hypothesis of the sentence. Number two, if I go to sleep early tonight, then I won't be late for school tomorrow. I go to sleep early is the hypothesis. A triangle is equilateral if it has three congruent sides. Remember that the hypothesis follows the if sign, so the hypothesis of this statement is it has three congruent sides. I'll know how to write biconditionals if I can identify a hypothesis and a conclusion. So that would be I can identify a hypothesis and a conclusion. Our vocabulary is a little different today. It's a prefix. Bi means two. We're used to this in bicycle, biannually, bilingual, many different words that we have in our language that uses bi, meaning two. So we're going to draw a line from each word in column A to its meaning in column B. Biannually, annually means yearly, so occurring every 2 years. Biathlon, athletics, a two-event competition, athletic competition. Bicentennial is every 100, centennial is every 100 years, so bicentennial is every 200 years. Bicoastal, having two coasts. The state of Florida is bicoastal. Biped, ped meaning feet, so a two-footed animal is a biped. Bipartisan is when a bill in the Congress is supported by both the Republicans and Democrats. It's bipartisan, so that's supported by two parties. And biplane, obviously a plane with two sets of wings. And biweekly, occurring every 2 weeks. So let's continue on talking about biconditionals. Let's talk about biconditional statements. A biconditional combines the P implies Q and Q implies P as P if and only if Q. So we're going to complete the biconditional statement. A ray is an angle bisector if and only if it divides an angle into two congruent angles. So a biconditional statement is true both going forward and backwards. I can switch the hypothesis and the conclusion, and it doesn't change the fact that the statement is true. So how do we write a biconditional statement? What is the converse of the following true conditional? If the converse is also true, rewrite the statement as a biconditional. If two angles have equal measure, then the angles are congruent. So first, let's identify the hypothesis. Two angles have equal measure. And then the conclusion follows the then, the angles are congruent. So now we have to ask ourselves, is the converse of this statement also true? So we're going to circle the converse of the conditional. If two angles are congruent, then the angles have equal measure. So now we're going to write the statement as a biconditional. Two angles have equal measure if and only if the angles are congruent. So that's basically how you write a biconditional statement. Now let's see how they identify conditionals in a biconditional. What are the two conditionals that form this biconditional? Two numbers are reciprocals if and only if their product is 1. So our P value is two numbers are reciprocal. Our Q value is their product is 1. So we're going to first write the conditional if P implies Q, or P implies Q. If two numbers are reciprocal, then their product is 1. We can now write the converse of that statement. If the product of two numbers is 1, then they are reciprocals. So we basically identified the two conditionals that combine together to make up our biconditional statement. The next thing we're going to look for is figure out how to write a definition from a biconditional statement. A definition of a straight angle is the definition of straight angle reversible. If yes, write it as a true biconditional. So the definition of a straight angle is an angle that measures 180. Reversible means you can reverse P and Q in the conditional. So let's first write the conditional statement. If an angle is a straight angle, then the measure is 180. Now the converse of this statement would be, and you go ahead and think about that now, if an angle measures 180, then it is a straight angle. Since this is a true statement, that a measure that measures 180 is a straight angle, we can write a biconditional. So we can say an angle is a straight angle if and only if it measures 180. And there are no other angles. The 180 is the only measure of a straight angle. So now we need to know, once we can write definitions, how do we identify good definitions? So we'll look at problem 4, identifying good definitions. Is the following statement a good definition? Please explain. A square is a figure with 4 right angles. So first let's write that as a conditional statement. If a figure is a square, then it has 4 right angles. That is a true statement. Let's write the converse of that, though. If a figure has 4 right angles, then it is a square. So now, is both the statements true? Is one of them true? Both statements true? Converse true? Of all those 2 statements, which one are true? And obviously, the first statement is true. If a figure is a square, then it has 4 right angles. But the second statement, a rectangle has 4 right angles, and it's not a square. So there's one counterexample to that statement. So the conditional statement is true. But so this isn't a good definition of a square because it doesn't define it fully. I mean, to say a better definition of a square is that it has 4 right angles and all sides are equal. So the converse of the conditional is not true, so we can't use this biconditional to define what a square is, so it's a bad definition. So let's sum up this lesson. It's a pretty simple lesson, it's not very hard, with our lesson check. We're going to compare and contrast. Which of the following statements is a better definition of a linear pair? A linear pair is a pair of supplementary angles, or a linear pair is adjacent angles with non-common sides that are opposite rays. So we're going to use figures below for our exercises. Underline the correct number or numbers to complete each sentence. Figures 1, 2, 3, 4 show linear pairs. So actually only one there that shows a linear pair is figure 3. Figures 1, 2, 3, 4 show supplementary angles. Well, 2, those are supplementary angles, and 3 are supplementary angles. So 2 and 3 both work there. Figure 1, 2, 3, 4 show adjacent angles. Figure 3 shows adjacent angles, and figure 4 shows adjacent angles. And finally, figures 1, 2, 3, 4 show adjacent angles whose non-common sides are opposite rays. Well, the only one there is 3. So underline the correct word to complete the sentence. Supplementary angles are blank linear pairs. And as we talked about this in class, all linear pairs are supplementary angles, but not all supplementary angles are linear pairs. So the correct answer is sometimes. Write a better definition of a linear pair. Well, that's your rest of your homework assignment. That's what you're going to do tonight. I want you to think about what would be the best definition of a linear pair, a better definition of a linear pair. So that's our lesson. I beat the 10 minutes. I'm under it by 20 seconds. So make sure you do your homework and make sure you get your notes filled in. If you have questions, mark them on your notes so that we can go over them tomorrow in class. Y'all have a good night, and I'll see you tomorrow in class.